Hello and welcome back. I hope you had a wonderful weekend. Thank you to everyone who uploaded their getting to know you or your introduction videos. If you're having problems uploading those to Flipgrid, you can always take just record them through your camera, the default camera app, and then upload them to the Google Classroom. If you are able to get into Flipgrid though, you'll be able to review everyone else's videos as well. If you upload them to Google Classroom though and they're not on Flipgrid, then they'll be private and no one can actually view them. Another thing is if you wanted me to make your video private, that's you can just message me through Remind. That'll be easier for me to get the message than through Google Classroom. Sometimes your messages in Google Classroom, the private comments, they get lost. All right, so moving on, we're going to go ahead and start our first chapter of the textbook. So this is in your textbook. It's called Stat Starts Here. It's just basically an introduction, but we're going to be talking about data. And some basic things here. So data is all around us. It's collected information of us. Our private data is that information is collected all the time. This is a good visualization of data because you're seeing all kinds of different pie charts like you see here. This is actually really a bad pie chart because it's three-dimensional. The problem with that is we see this extra face or this extra surface in the front makes this section of the pie look bigger than the parts in the back that don't have that front surface showing. So we actually never use 3D graphs even though it looks good. This violates the area principle, which we'll talk about more. It looks like we have some segmented or side-by-side bar charts as well. Segmented bar charts with different segments broken up here. More segmented bar charts and some other funky cool stuff going on over here. Anyway, so data, a lot of it, kind of looks like numbers, but if we can graph it out like this time graph here or this time plot looks like, we can see patterns much more easily. We can see differences between areas that maybe are not lining up like we would want them to. So anyway, visualizing data, knowing how to visualize the data by categorizing it and then making an analysis from the data, that's really what we do in statistics. And especially our first unit, we'll be doing a lot of these graphs for one-dimensional or univariate data. It's kind of like one-dimensional. See if I can. There we go. All right, so the first question is, what is data? So data is systematically recorded information, whether it's numbers or labels, like a favorite color, green, blue, that would be considered like a label, together with its context. So that's a very important part, is data without its context is pretty well meaningless. So here's a bunch of data from Amazon, but without its context, without the labels of each variable, it's kind of meaningless. We might be able to figure it out though. So here we got a bunch of numbers. Does anyone know what that means? No idea. If I had to make a guess, that might be an order number. So these could be order numbers. And then here, this obviously those are the locations, not just the state, but also we got Canada here. So that might be, I don't know, where it's shipping from, or that could be the location of the buyer, where it's shipping to. I don't know. It looks like we got counties here. Bad Blood, Best of Kansas. I don't know. I don't know what this is. That could be some sort of title. Mammals, Camas, Chicago. Okay, this is a mess, right? Is this the price? I don't know. There's no units, right? So that's kind of bad. So yes or no, I get that part. I did some kind of serial number, and then that's probably the person purchasing it. I don't know. So anyway, the problem is with this data, even though it's organized in the table, laid out nice for us, where we've got our variables or the columns, and each row here is going to be each individual case, or each order in this case. I know that, but without the actual the titles for the variables, it's kind of hard to figure out what we've got here. So it's very important to have the data along with its context so that we can really make sense of it. So here we actually have the context. So this order number, name, state or country, price, area code. Okay, I wouldn't have gotten that. Previous album that they downloaded. Okay, I didn't know that. Was it a gift? Amazon serial identification number, I'm guessing, and then new purchase artist. All right, so that's good. So data tables, an arrangement of data in which each row represents a case. So this is an order number, which would be a case, an order, right? And each column represents a variable. The variable holds the information about same characteristics for many cases in this case. So we have all the different prices for all the different 5 cases that they're showing. The vertical columns of the data tell us what, which is the variable. The case, an individual about whom or which we have gathered data. Typically horizontal rows of data table tells us the who. The context tells ideally ideally tells who's measured, what was measured, how the data was collected, where the data was collected, when and why. So it's your 5 W's and your H, right? And the study, why the study was performed. At the very least, we must know the who and the what in order to draw meaningful conclusions. So that would be your column and your row. We need to know what we're measuring and who it's about, right? Along with the how. So how is the data collected so that we can make sure that it was randomized, so that we can actually make sure we can reduce the effects of bias and make sure that our statistics are actually representative of our samples, of our population. So how the data was collected to determine if the sample is representative of the population, essentially. All right, so who is the population and the sample? The what is going to be the variables. What information are we gathering? Where is the location of the population of the sample? We're only talking about the U.S., or we're going to talk about orders within Oklahoma. That would be our population or our sample. When is the time the data was collected? That's pretty important if we take old data, and we can't assume that that's still true, right? Like political polls, even political polls from a month ago or last week could be outdated. So it's very important to, when we're publishing, we tell when the data was collected. And then what was the method that we used for collecting data? Again, very important to make sure that it's representative of the population. All right, so with gathering data, we've got surveys or studies, and then we have experiments. So we're going to spend a whole unit 3 on gathering data, which will get much more in depth here. We're just kind of a brief overview. So a survey or an observational study is, the observational is a passive study where you're just making observations in nature without actually manipulating what's going on. And then a survey is, of course, where you send out information or you're polling other people. So, for instance, I think this was the Electoral College from 2016, the 2016 election. Then, when we're dealing with experiments, this is where we can prove a causal relationship with experiments as long as we're randomly assigning treatment groups. So this is what we use with like a placebos in your science courses and stuff. So we'll get in more into those details later on. So a respondent is someone who answers or responds to a survey. So that's when we're talking about surveys or studies. An experimental unit is an individual who participates in an experiment, who is randomly assigned in a treatment group. If it's a person, they're called a participant. If it's not a person, we would just call them a subject or an experimental unit, but we usually call them participants if it's a human, to give the respect there. All right, the record is the information about an individual in a database. So if we access a record or records for something, then that is information. Like, for instance, if we're looking at so in the Olympics, and we're looking at who won the Olympics or the Tour de France or something like that, then that we'd be accessing records instead of actually asking people who won. So that's just another form of gathering data if we have official data, or like who won the Super Bowl each year for the last 10 years, that would be records that we're accessing. So with a survey, we send out surveys to a sample of the population. So the population is the group that we're interested in altogether. So if we're talking about politics and elections, if we're asking people who they're going to vote for or something, the population would be all U.S., so all voting adults or registered voters in the United States. Okay. Now, we cannot send out a survey to everyone. That would be a census. That's way too expensive. We don't even do those every year, I don't believe. So instead we take a sample, and a sample hopefully is representative of all the people of our population. We ensure that it's representative by making sure that it's randomized. But anyway, a sample is going to be a subset of the entire population. So you can see that in our Venn diagram here. Hopefully our sample is representative of the population so we can draw valid statistics from it. Same thing with an observational study. I think I skipped one. Yeah. So when we have, there are three different types of variables. Okay, so the first one's called an identifier variable. We don't really deal with those too much. It's basically kind of like a social security number. It might be a number itself. It usually is a number, but it doesn't have any meaning to it. Like, it doesn't have a unit involved. So like an order number, for instance, is an identifier variable. Its sole purpose is to identify which case. So a social security number would be an identifying variable. The order number for these Amazon orders, those are also an identifier variable. So it's a categorical variable, meaning it splits them up into categories, like for instance a person by a social security number. So if we were listing these people by their account number or something, if we had multiple orders, that would tell us it was the same person. And so the sole purpose of that would be just simply to identify the person. So that records a unique value for each case, is used to name or identify it. So that's fine. A categorical variable means that it's split up into categories or buckets. So these usually don't have units associated with them, and they're usually words, but they also could also be numbers. So categorical, the main thing is it splits it up into categories or like bins, and it's like we're sorting something out in a bin. Quantitative variable, quantitative referring to a number, it does have units, which numbers act as numerical values. Quantitative variables may also have units. Units are a quantity or amount that's adopted as a standard unit, standard of measurement, such as dollars, hours, or grams. So you know what units are. So if we go through here, we can identify with each one of these what kind of a variable it is. So our order number, of course, is going to be an identifier variable. The name is telling us, you could look at that either as identifier or categorical, because we could be splitting them up into categories, but the category would just be the person. So if somebody ordered the same one person had multiple Amazon orders, we would group them into the same category for the same person, but more than likely this is being used as an identifier variable. State or country, that's categorical because we're breaking them down into groups. So we would have all 50 states would be our buckets that we're sorting, or our bins that we're sorting into. So and then Canada and others would also have their own bins, of course. So that would be categorical. Price would be a quantitative variable, and it has units, which would be US dollars in this case. The area code is a number, but it's not actually a quantitative variable because the numbers don't really have a meaning, except I believe the area codes further to the east are smaller numbers and to the west are larger, but no, I don't even think that's true. So the area code numbers are just simply categorical. So all the information we can get from it is that if it's the same number, that means they're from the same area code. So that's pretty much how that works. Previous album downloaded, this is going to be categorical. So we break those into all of the Nashville albums or Bad Blood albums, etc. Is it a gift? Yes or no? That's categorical as well, just with two bins. The Amazon serial identification number, that's going to be an identifier variable as well. So that's going to help. It's just a number associating, so we can help figure out what item is being purchased. And the new purchase artist, that's going to be categorical as well. All right, so a variable is an attribute or a characteristic. We have three. So we're going to sort these into, are they categorical or quantitative? So gender, male or female, that doesn't have units, so that would definitely be categorical, and with two categories there. Political affiliation, liberal, moderate, or conservative, that's categorical as well. Number of siblings, so our units would be siblings, and so this would be quantitative. And then number of states that we visited, that would be quantitative as well. Just some number. Shoe size, that would be quantitative as well. And I think that's it for that. So what is a statistic? So data, or a datum, is an individual variable with its context. So the who and the what, along with how we collected it. But a statistic is a summary from the data that we've collected from a sample or an observational study or analysis of our experiment. So a statistic is a summary or numerical summary of data, such as an average, a proportion or a percentage, or a rate or a slope, in other words. Okay, so in 2014, 78.7% of people in an accident were wearing a seatbelt. Okay, so you might have seen this poster before. It says, "Don't be a statistic, buckle up." So you'd be a part of a statistic. You wouldn't actually be a statistic itself. You'd be anecdotal, right? So you'd be a datum technically. You'd be one individual datum that together gives us a statistic. So that's what they're essentially trying to say there. All right, so let's say that we wanted to do a study on bears in Colorado. So we wanted to be able to, from afar, be able to, from the height of the bear, estimate the weight of the bear. And so there's a certain number of bears that we captured, and we weighed them and we measured their heights. So here we have their heights in centimeters and then their weights. And we plotted those out. This is bivariate data because we're talking about two variables and how they relate to each other. So whenever we plot that out, we could also, form a line of best fit, and then that would give us the slope, or what we think the rate is. So as they increase in height, how much do we expect on average for their weight to increase as well? So then if we find a bear that has a certain height, we can estimate what their weight is without having to seduce them. All right, so first question we have is, what would our population be? So what's our population of interest? Well, we're interested in posting a rate on what is the relationship between the height and the weight of bears in Colorado. So we're interested in all bears in Colorado. Our sample is going to be the data from the specific bears that we selected, that we sedated and measured. Our variables is the information that we're collecting. In this case, there are two variables, bivariate data. We have the height and we have the weight. That's the two things that we were interested in. The data is going to be, or the datum are going to be each individual piece of data, which is going to be a set of heights and weights for each individual bear that we collected. Then the statistic is a summary that we gather from that information, which in this case would be the line of best fit, the slope and the intercept, in other words, for the summary of that data. And that's what we would post. So we would say on average, we give the slope or the line itself in our actual statistic. All right, so here we have, this is some records of the winners of the Tour de France, I believe. Their total time, you can see each one of those statistics there. All right, so our question here is what is the who? So what is our population, our sample? So what is our population of interest? Well, we would be talking about all the people that won the Tour de France from when it started in 1903 all the way to the most recent ones if we're accessing a database. Our sample in this case looks like we only have information from some of them, or we have all of it, so it could be a census. But anyway, our who is going to be all of the winners of the Tour de France. The what is the information we're collecting, year, winner. It's going to be all of our titles here. Our columns are going to give us our variables, which is the what, our information that we're gathering. The where is we access this, you could say Tour de France, which is in France, of course, or where we access the information, Wikipedia or something like that. So it's a location of the population sample, so we would probably go with France. When the data was collected, so that would be the most recent date that we accessed the data, but this is a record, so that's not as important. And then how the data was collected, well, we access the record by looking it up through Wikipedia or something. All right, so we've only got 3 problems on the homework, so if you want to go ahead and get those out, what you might want to do is open the PDF on Google Classroom. It'll open in a PDF editor that's built into the web-based HTML Google Classroom or the app that you're probably on the iPad. Then you'll be able to write with your finger on the iPad and then submit that and turn it back in through Google Classroom. You also could print out the assignments if you prefer, and then take a photo and upload that to the Google Classroom and turn it in that way if you want. So you probably want to be moving the video to your phone or a computer or whatever, laptop, whatever you have access to, and then on your iPad you'll want to open up the assignment through Google Classroom. So number 1, it says voters. February 2007 Gallup poll question asks, in politics as of today, do you consider yourself Republican, Democrat, or Independent? The possible responses were Democrat, Republican, Independent, other, and no response. So what kind of variable is the response? So is this categorical, quantitative, or an identifier variable? So in this case, it's clearly going to be categorical. We're breaking them down into bins or buckets. We're sorting each individual person into several different categories or groups, such as Republican, Democrat, Independent, Other, or no response would be the last one. Number 2, mood. January 2007 Gallup poll. Question asked, in general, do you think things have gotten better or worse in the country in the last 5 years? Possible answers were better, worse, no change, don't know, and no response. What kind of variable is this? So is it categorical? Is it quantitative with units? Or is it an identifier variable that might be numbers but just simply identifies an individual, like a serial number? So in this case, just like the last one, it's going to be categorical. We're splitting them up into groups or bins or categories, our categories would be better, worse, no change, don't know, and no response. So those 6 categories altogether. Number 3, medicine. Pharmaceutical company conducts an experiment in which subjects take 100 milligrams of a substance orally. The researchers measure how many minutes it takes for half of the substance to exit the bloodstream, so the half-life. What kind of variable is the company studying? So it looks like in this one, we're interested in the half-life. The variable, is that going to be quantitative, categorical, or an identifier? So the half-life is going to be the amount of time. So whether we're measuring it in seconds, minutes, hours, or days, or however they're looking at that, it is going to be time. So is time going to be broken down into categories, or is it going to be quantitative? Now, technically, this could be both. So it depends on how they want to break it down. So do they want to break it down into categories like 0 to 2 hours, and then 2 to 4 hours, and then 4 to 6 hours? Probably not going to break it down into categories like that. More than likely, it's just going to be recorded as the exact amount of time and be used as a quantitative variable. All right, so also when we do have the textbooks, we're still working on, hopefully sometime this week, we'll be able to have you guys come up to the school to pick up your calculators and textbooks. I'm still working with Stinnett on that and some of the other AP teachers. But the odd problems you'll be able to look up in the back of the book, so that'll help you out on at least half of the problems that you're working here. But we totally just did the assignment together. So if you watch the full 22-minute video or whatever, congratulations, you're done for the first day. We will slowly get into needing to use the calculator, and the lectures will get longer. But that was 9 pages worth of our first chapter that we just lectured through and worked the examples. So we're already basically 10 pages in. If you want to, you'll notice on the assignment I've got the vocabulary words and the references to the page numbers of where you can look them up if you were not sure about something that we went over. You can also always go back in the video if you want as well. And the last thing is you can change the playback speed, so you can speed up or slow down, just depending on how fast you can process what I'm talking about. All right, so that's it for today. I'll see you guys tomorrow.